Hi, welcome back to Science 1206, the Weather Dynamics Unit. I'm Ms. Ledwell, and in this video, we'll talk about global wind patterns. Let's begin. The rotation of the Earth on its axis affects wind and ocean currents. As Earth spins from west to east in a counterclockwise motion, this movement causes the Earth's winds and ocean currents to turn and be redirected. This change in the direction of moving air, water, or any objects on the surface caused by Earth's rotation is called the Coriolis effect. In the northern hemisphere, air masses and winds are deflected to the right of their initial direction. In the southern hemisphere, air masses and winds are deflected to the left of their initial direction. Early sailors discovered that in certain areas the winds tend to blow in the same direction most of the time. They noticed that if they sailed south close to the equator, the winds would blow to the west from the east. As they traveled further north, they found that the winds would blow most often to the east from the west. This regular pattern of winds is known as prevailing winds. Global prevailing winds result from the combination of convection currents produced by the uneven heating of Earth's surface and the Coriolis effect. There are three major wind systems which occur in both the northern and southern hemispheres. We have the trade winds, the prevailing westerlies, and the polar easterlies. We'll look at each of these major wind systems in more detail. First, let's look at the trade winds. The trade winds occur between the equator and 30 degrees north and south. The trade winds form when the intense sunlight at the equator warms up the air right above the equator, making this air lighter and causing it to rise. As this warm air rises, it leaves behind an area of low pressure. The rising warm air moves away from the equator and starts cooling down. Cooler air is heavier, so eventually this air begins to sink back down to Earth's surface around 30 degrees north and 30 degrees south of the equator. Once this air sinks, it starts moving back towards the equator, trying to fill in the low pressure area left when the warm air rises. This movement creates a loop. The air moves from the higher pressure areas near 30 degrees north and south back towards the lower pressure at the equator. This constant flow towards the equator is what we call the trade winds. The trade winds are deflected west. The trade winds are a crucial part of Earth's climate system, helping to regulate temperature and weather patterns around the globe. They were also historically important for sailors who relied on these predictable winds to navigate the oceans. Let's look at a diagram showing the location of the trade winds. On our diagram, we notice the equator, and we have 30 degrees north and 30 degrees south marked off. The trade winds will occur between 30 degrees north and the equator and 30 degrees south and the equator, and they move towards the equator deflected to the west. Next up, we'll look at the prevailing westerlies. The prevailing westerlies occur between 30 degrees north and 60 degrees north and between 30 degrees south and 60 degrees south. So on our diagram, we see 30 degrees north and 60 degrees north, and we have prevailing westerlies there, and 30 degrees south and 60 degrees south, and we have prevailing westerlies there. And notice the deflection here is to the east. The air circulation pattern is opposite to the trade winds. The surface winds blow west to east and towards the poles. The prevailing westerlies in the northern hemisphere are responsible for much of the weather in Canada and the rest of North America. Now we'll look at the polar easterlies. The polar easterlies occur between 60 degrees north and 90 degrees north, which is the North Pole, and between 60 degrees south and 90 degrees south, which is the South Pole. So on our diagram, we see 60 degrees north marked off, and the North Pole is indicated. The polar easterlies occur in this region, and 60 degrees south is indicated, and the South Pole is right here, and we have polar easterlies also in this region. The air circulation pattern of polar easterlies is similar to that of the trade winds. In the regions close to the poles, the air becomes cold and dense. It sinks and moves towards the equator. The surface winds blow east to west and away from the poles. Now let's look at an animation of global winds. Radiation from the sun hits the Earth's surface at different angles. So we have uneven heating on the Earth's surface and surrounding air. The warmest air is at the equator and the coldest at the poles. Warm air from the equator rises toward the poles and cools, forming a convection current or cell. Cold air from the poles sinks towards the equator, cools, and forms another convection current. A third convection cell is created between the other two. A total of 6 convection cells, 3 for each hemisphere, are created. Prevailing winds blow east and west due to the uneven heating of the sun and Earth's rotation, the Coriolis effect. The rotation of Earth creates the Coriolis effect that twists winds to the right or clockwise in the northern hemisphere, and the left or counterclockwise in the southern hemisphere. The area around the equator is a calm, low-pressure area with little or no wind. It's called the doldrums. Trade winds are east to west winds that blow 30 degrees north and 30 degrees south. Westerlies are winds that flow west to east, between 30 degrees and 60 degrees latitude. Polar easterlies are winds that carry cold Arctic air from the poles toward the lower latitudes. These are prevailing winds that blow in a constant and predictable pattern. Now we'll look at a summary of points about global winds. There are 3 major global wind systems which occur in both the northern and southern hemispheres. We have the trade winds, the prevailing westerlies, and the polar easterlies. Global wind systems are named for the direction from which they originate. Global wind systems result from the combination of convection currents and the Coriolis effect. The Coriolis effect causes winds to bend to the right in the northern hemisphere and bend to the left in the southern hemisphere. Air moves from an area of high pressure to an area of low pressure. These wind systems play a critical role in shaping the weather patterns and climate of a region. Now it's time to continue to the next video. Before you do, take a 30-second break, stand up and stretch, then continue on to the next video.